Hello and welcome to the latest Rampart AI Fast Chat. Today, CEO of Rampart AI, Lee Krause, and our special guest, Douglas Schmidt, Professor of Computer Science at Vanderbilt University, will talk about the benefits of removing application bloat. So let's start by explaining what application bloat is and then go from there.
So I think I can take this first one. So to me, bloat is any unnecessary files, dependencies that exist in the application. And I kind of look at it as two layers. There's a layer that you can look at it from a container standpoint of bloat associated with the container, which to me is the easier component. And then there's the code itself, which you'd have methods or unnecessary code that exists in your system that's just basically making it more confusing, and you may want to do refactoring on it later on in date at some point. But I think, at least for me, the easiest aspect is the container side of it. You can get immediate benefit by removing files and dependencies that don't need to exist. What's your take, Doug?
I think of course, I agree with everything you just said, Lee, but it's also worth characterizing different types of bloat. There's bloat that occurs because people have added features that aren't necessary for some given use case or some given configuration or customer. There's bloat that occurs because there's excessive memory that's being used, too much memory allocated, perhaps again for data structures that don't need to be done that way or are not used in all circumstances. And of course, there's also disk bloat, where the bloat takes up space on the disk. All of these things can degrade performance and introduce opportunities for attacks, as we'll talk about here in a second. Sometimes there are moderate, modest benefits of bloat, especially if you have a system that's going to be evolved quite a bit, and so you have some base level capability that you can add things to, but usually that pales by comparison with the risks and the overheads that are introduced.
Yeah, totally agree with that. That's good. um, let's talk a little bit about bloat and attack surface, because I think that's something where people don't understand that they're adding risk at really no benefit. And I break it down in my mind as to two things. One, attack surface with truly methods or additional code that exists that doesn't need to be there, that may have vulnerabilities in it that you're basically increasing your attack surface for. And the other side of it is that in the container world, you may have functions or tools that are included in the container that allow people to initiate the attack. So that it's kind of the vulnerability itself, as well as tools that allow you to deploy the attack, are kind of the two attack surfaces that I think people need to be aware of. And by simply removing them, you actually take them off the table. This is how I view that world. How do you see it, Doug?
Yeah, absolutely. Just to kind of put a nice little summary on what I think we're talking about, more features leads to more risks. Obviously, the more you have exposed in terms of APIs or other capabilities that are something that the attacker can use, the more likely you are to have problems, especially when you're dealing with infrequently used libraries or code bundles where you've got a lot of code that is not necessarily used a lot, so they may not be tested or maintained regularly. Speaking of maintenance, when some components become outdated, maybe it's several versions back, but they're maintained or kept in the container for backward compatibility reasons, people often have a tendency not to spend as much time on the care and feeding and analysis of those components. And of course, the other thing that underlies all this is the bigger the system in general, the more complex, and the more complex, the higher the opportunities are for things to go awry. And so much of this stuff is just human error. People get bored, they get tired. And that's why I think, as we're going to talk about, the need for automation and tool support and automatic analysis is so important here, because it can keep track of things that humans can't keep track of because they get distracted.
Yeah, I think it's really interesting when you talk about it in that context, that, there's a big push to put everything into containers themselves, just making it more portable, easier to move around. And I think that what people don't realize is that by making their containers the smallest possible, they're actually allowing the system to run more efficiently. So not only do you reduce the attack surface, but you're actually improving the efficiency of your system, the amount of time it takes to deploy your system. There's a lot of benefits, and I think that we forget about that. A lot of our focus is on the development itself, but at the end of the day, it's the deployment and how it runs at deployment, which is really how you make your money.
And I think there's a nice corollary here between minimizing containers and keeping them focused on a relatively small set of capabilities, and the movement towards microservices in the system architecture world, software architecture world for web-based systems in particular, rather than having big monolithic applications with lots and lots of APIs that are all glommed together in a somewhat undifferentiated spaghetti-laden way. Breaking things up into smaller parts makes it easier to test things individually. It makes it easier to analyze and develop and review things individually. And so those types of simplifications, by keeping things, doing a smaller set of capabilities and then using tools to combine them together and orchestrate them, is definitely the way the world is moving these days.
Yeah, yeah, yeah. So you touched on automation, so let's play with that. And I'll let you go first because I know you have some really neat things and views. How do you think automation can really help the kind of bloat side of the house? And it's really broader. I think bloat is the end result of what's occurred. What type of automation can be used to basically allow us to have better code that has less bloat, that runs more effectively?
Automation can be used in many different ways. There's automation that we would use during development using various tools that can help to start with a base image, a minimal base image, using, for example, stripped down operating environments like Alpine Linux versus the full-blown Red Hat or Ubuntu and so on. I think that way we start with something smaller, using things like multi-stage builds that frameworks like Docker supports are important. Having tools that you can go in and analyze your binaries to look for dependencies that are unnecessary, where you have coupling that doesn't need to be there. They're tools that can go in and analyze so you can strip apart and break your code into more minimal subsets. Being able to do updates and audits that are automated, where you can go and run a battery of regression tests or regression tools to look for these inconsistencies and inefficiencies. I know that there's also tools for dependency management and things like Maven and pip for Python and npm for Node.js and so on that can be used to manage dependencies. And then, of course, I'm sure we'll talk further about this, tools for doing analysis of vulnerability scans. Very important. People just have a hard time identifying all these problems, especially at scale. So anything we can do to get automation is going to be a way to augment humans and make them more effective at using their brain power for something that doesn't require kind of mindless churning through all kinds of rules and different vulnerability database scans and so on.
Mhm. I think also it's important to realize that there's some simple things you can do that just allow you, as part of your build process and deployment, just to basically minimize the container itself. Just that one aspect of it and it's really of no cost to you. There's only a net benefit in reducing the size and reducing the attack surface. And I think at each stage of that education, which you brought out, you can ultimately continue to improve it, another step within the pipeline to make it better. But I think there's simple things people can do today that will greatly improve their system and get even to the point where you're getting all the way back into refactoring your code using large language models and things of that nature to do the refactoring. All could be part of that whole automation, and including tests along the way, as well as how we deploy our code. And I think that those things are exciting and exist today. It's not something that we can't do today. So I know you spent a lot of time, whole use of patterns, design patterns, things of that nature. And now that we're seeing with large language models, the ability to do refactoring and potentially factoring associated with patterns, do you see that as a viable way that we could actually not only remove both, but greatly, I guess, improve the efficiency and effectiveness of the code that we've written?
Absolutely. And first thing to do is to learn what not to do. There's lots of so-called anti-patterns or common traps and pitfalls that developers often stumble into when they're trying to develop containerized systems. And we need to be mindful of not applying these anti-patterns in developing the system. So a good example would be building caches where you don't need to build caches. That can end up creating bloat and have things be inconsistent. Ignoring multi-stage builds. I mentioned before the Docker multi-stage build feature, and this allows to be able to separate out the build time environment from the runtime environment. that's a really good thing to be aware of.
Really
And
big thing.
totally.
People are not aware of that. That's true.
And there's also other, again, not just focusing on Docker alone, but Docker is a widely used container infrastructure. Not using the Docker ignore file properly, avoiding doing the analysis for the regular dependency updates, including application data inside of containers as much as possible. Of course, we want to make the containers stateless and then have the data coming from some other location, typically a database of some kind. And there's other, more sort of very tactical things like avoiding overuse of the latest tag when pulling base images, which can include other behavior that we don't necessarily want and haven't taken the time to analyze. So lots of things that people do wrong. With respect to using large language models, there's some very, very fast breaking or late breaking technologies that have come out in the last couple of weeks, one of which is called Code Inspector. And it's doing a very good job now of being able to take large corpuses of software or corpora of software and be able to analyze it with various properties in mind. And so I strongly encourage people to at least begin to explore these tools. They may not be ready for prime time everywhere yet, but they can provide a great deal of insight, especially in large code bases where no single person has a bird's eye view of how everything is working. And they can give you that kind of perspective. And of course, when they're coupled with other analysis tools and testing tools, they can get even further. And so I think we're going to see a lot of developments very soon in terms of orchestrating large language models with pulling in other types of analysis tools to provide a more comprehensive end-to-end analysis of dependencies and security properties and so on in these software systems designed for containers.
So with all that, within your students that you work with and consulting that you do, are you seeing improvements in code? Are we getting better? You know what I mean? Or is it just people want to be artists and are always going to be artists?
I think people who are concerned with quality and who are in an environment where improved quality is incentivized and encouraged are seeing that. Unfortunately, many organizations are about billable hours and number of lines of code, and there are all kinds of perverse incentives that
Yeah.
discourage people from reducing stuff. In fact, a classic problem here that I'm sure you're aware of with bloatware, if people are paid by line of code, they're not paid to remove code. And so there's often these perverse incentives where people are motivated to add stuff as opposed to remove it. And of course, we all know from the work in security and optimization and so on, you can often get better benefits by shrinking things, by enlarging them. But until we get the incentive systems set up to reward that, it's often hard to do that.
That's really interesting. It's hard to change behavior. We're going to game it, right? Yeah. That's a really interesting point that although we have all these tools and things in front of us, that's not really what you're getting rated on at the end of the day.
Well, a good example of this, and this is really related to what we're talking about, there's been the emphasis on reuse, or at least the promise of reuse for decades and decades. And reuse is a great thing. And I think today most people do practice reuse because nobody wants to write all the capabilities in modern middleware and modern operating systems from scratch. However, back in the day when people were told to reuse stuff, they were often also motivated financially to write more things. So reuse would, again, shrink the amount of code that they wrote, let somebody else get the credit. And we had a really hard time 10, 20 years ago convincing people to have systematic approaches to reuse because that's not the way that they were rewarded and incentivized.
So, that's kind of interesting on that too. From a security standpoint, open source code, reusing code, how do we use it to our benefit as opposed to our demise? The fact that we're using code that may not have been written by the organization, or we may not even have a great understanding of how it works. What I mean, from a security standpoint, I know we're going a little bit off topic, but I'd love to hear what you have to say.
Sure. So one of the nice things about open source code is if it's reasonably well written and widely used, it's also amenable to analysis by all kinds of tools, and also the famous quote about to enough eyeballs, every bug is shallow, which is not entirely true, but it's probably not too far off from being true. But certainly the case that if you have a code base that can be analyzed by different people, either manually or automatically or semi-automatically, over time, it's more likely that the error legs will get removed from that code. In contrast, if you have closed source code, then you often have no earthly idea what type of pedigree or what type of analysis has been done to it, you may be unable to apply more advanced static or dynamic analysis techniques on that code because you don't have access to the source and therefore can't do as thorough of a job of analyzing it. Now, of course, the devil's in the details. There's plenty of open source code that's full of security vulnerabilities and is poorly written, just as there's great open source code that benefits from a community. But I think that's the real thing. It's about the ecosystem. And if you have a good ecosystem where you have many stakeholders who are focused and incentivized to work together to improve and update the software quality over time, that's probably a better outcome with respect to security and performance and so on than something that's completely closed off and nobody really knows what's happening under the hood.
Interesting, interesting. So when we look at just kind of going back, if you were to give your top three things that people should take into account to minimize bloat within their applications, what would your top three be?
Well, I think we should think about the benefits of taking the time to do this. So being able to deploy your software components, your containers faster, that's a big thing to keep in mind. Being able to improve security, super important, especially nowadays where there's more and more bad actors out there trying to exploit systems, as we see all the time with all the data breaches. The ability to reduce maintenance and evolution costs, super important. Software has a technical debt dimension, and if you don't pay it up early enough, you'll pay it down the road. You can't escape these things. And other things that are kind of related, more efficient resource management, more cost effective because you don't have to worry about transferring large amounts of data. Some cloud environments will bill you based on the amount of disk space you use, the amount of memory you use, the amount of network transfers you do. So overall, focusing on these optimizations and ways of reducing the dependencies and avoiding the bloat is going to give you a win across a nice wide spectrum of benefits.
Mhm. I guess I'll just add my 2 cents onto that because I think it very well said and to the point. The one thing that I would add is that matters most at deployment. Try to minimize the containers that you deploy because you'll get immediate benefit from there with very low cost to you in an automated fashion, and you can get immediate benefit. And I think that as people start to do that, they can continue to move up the ecosystem to continue to make more and more improvements to how we develop software would be better for everybody.
Totally agree.
Thank you both for lending your expertise on the subject. To our listeners, leave us a comment and let us know other security topics you're hoping to learn more about, and we'll make it happen. Until next time, stay secure.